Imagine you're sitting in your next board meeting. You have to look your shareholders in the eye and explain why, like, a piece of optimization software your team deployed just cost your company up to 30 million euros.
Yeah, that's a rough beating.
Right. Or, I mean, depending on your scale, it could be 6% of your entire global revenue. That is the staggering kind of existential reality check facing European business leaders and CTOs by the end of this year, 2026, if you are not compliant with the EU AI Act.
It's massive, and it's coming fast.
It really is. Okay, well, let's unpack this. To figure out how to navigate what is arguably, the most complex regulatory shift in modern tech, we're pulling from a pretty heavy stack of sources today.
We've got a lot of ground to cover.
Yeah, we're looking at the latest legislative drafts of the EU AI Act, a highly revealing 2025 Gemini Enterprise Readiness Survey, McKenzie's latest report on agentic systems, and some really cool proprietary case studies from AetherLink's consulting arm.
Oh, those are fascinating.
Yeah, and the data from those sources paints a terrifying picture, honestly. Like, 73% of European enterprises are currently flying completely blind with these massive gaping holes in their AI governance.
Which is exactly why we're tearing into this topic on the AI Insights by AetherLink channel right now. Because look, we are staring down a hard operational bottleneck for 2026.
Yeah, it's not a future problem anymore.
Exactly. If you're a mid-market or enterprise organization, especially, if you're operating in heavy tech and manufacturing hubs like Eindhoven, this isn't some vague legal headache you can just toss over the fence to your general counsel.
Right. It's not just a paperwork thing.
No, failing to lock down your architecture right now means severe operational disruption. Like, it means an inability to deploy new models, losing the trust of your B2B customers, and essentially being permanently locked out of lucrative EU public procurement contracts.
Wow, so you just can't do business.
Pretty much.
Yeah.
The whole mission of our deep dive today is to transition your organization from a state of reactive panic compliance into a state of proactive competitive advantage.
Oh.
Because compliance has fully migrated from the legal department right into the core CI/CD deployment pipeline.
That's such a huge shift. And I want to look closely at the actual rules of the game here, because the terminology can get really muddy.
Oh, absolutely.
So the EU AI Act categorizes AI systems into 4 distinct risk tiers. You've got prohibited, high risk, limited risk, and minimal risk.
Right?
And think of this like building codes for software. You wouldn't build a 50-story skyscraper using the safety permits meant for a backyard garden shed.
That's a great way to look at it.
Right. Like, if your team is spinning up a simple internal chatbot to, summarize marketing meetings, you're building a garden shed.
Yeah, minimal risk.
But if you're deploying something that directs physical operations, allocates resources, or makes critical financial decisions, you are building a skyscraper. And the regulators are going to inspect the metallurgical integrity of every single steel beam.
And I think the problem is that many CTOs and business leaders just completely misjudge what constitutes a skyscraper.
They assume it's just like the crazy sci-fi stuff.
Exactly. They assume high risk only applies to things like facial recognition or autonomous vehicles. But if you look at the actual text of the act, if you are in manufacturing, logistics, or critical infrastructure, your day-to-day operations likely cross that threshold automatically.
Wait, automatically, just by being in logistics?
Yeah. Systems that manage supply chain optimization, automated production scheduling on a factory floor, or even predictive maintenance for robotics, those are explicitly classified as high risk.
Oh, wow. So a ton of companies are in that bucket without realizing it.
Yep. And once you cross that line, the regulatory burden scales exponentially. You're suddenly required to maintain ISO 9001 level quality management systems directly integrated with your AI. You need documented impact assessments.
Okay, let's pause on that, because when you say ISO 9001 level quality management and transparency records in the context of machine learning, what does that actually look like to an auditor? We aren't just talking about a PDF sitting in a shared drive, are we?
Oh, not at all. A transparency record under this framework is a highly technical, searchable database.
Okay.
Like, if your algorithm decides to reroute a supply chain shipment and that results in a delayed delivery of raw materials, you can't just tell the auditor, well, the neural net optimized for cost.
Right, the black box excuse doesn't work anymore.
Exactly. You have to produce a cryptographically secure log showing the exact weights, the specific training data parameters, and the real-time inputs that influence that specific decision at that exact timestamp.
Wow.
Yeah, you essentially have to prove the mathematical provenance of the decision.
Which brings us to a massive disconnect in the market. Because That 2025 Gemini survey looked at this exact readiness across European organizations.
And the numbers are grim.
So grim. They found that only 41% of organizations have any kind of formal AI governance framework. And the technical execution is even bleaker. A sub 28% actually have documented AI risk assessment processes that align with that high-risk classification you just broke down.
Less than a third.
Less than 28%. So over 2/3 of the companies out there are just like deploying models and hoping the regulators don't knock on their door.
Which is a terrible strategy.
Yeah, and I was reading through the McKenzie report in our source stack, and it points to a specific technological shift as the main culprit for this governance gap. They keep talking about the rise of agentic systems.
Ah, yes, agentic AI.
Yeah, help us understand how an agentic system differs from what companies were doing, just 2 years ago, and why it's breaking everyone's compliance models.
Well, 2 years ago, enterprise AI was largely static.
Right, like standard machine learning.
Exactly. You had a model, you fed it a CSV of historical data, and it predicted customer churn or flagged a fraudulent transaction.
And she just gave you an output.
Right. It provided an output, and then a human decided what to do with it. Agentic AI fundamentally alters that workflow. An agentic system doesn't just give you an answer. It takes an open-ended goal, breaks it down into multi-step workflows, and physically executes those steps autonomously across your APIs.
So it's actually doing the thing, not just recommending it.
Yes. It's reading the data, formulating a plan, and then actively purchasing raw materials, adjusting factory thermostat controls, or negotiating vendor contracts.
The McKinsey data backs up how fast this is moving, too. They report that 62% of organizations are already piloting these agentic systems.
But barely any have the governance.
Exactly. Only 19% have the governance to handle it. And I have to push back here on the pure mechanics of this, because how do you even govern a system that makes real-time, multi-step decisions while your entire engineering team is sleeping?
It's tough.
I mean, if you require a human to approve every single micro-decision the AI makes at 3 a.m., you completely break the automation you just spent millions of euros building.
Right. What's fascinating here is that you've hit on the core tension of modern AI deployment. Traditional manual oversight completely collapses under the speed of agentic systems.
Yeah, humans are just too slow.
Exactly. So the organizations that are actually solving this, the ones falling into that compliant 19%, they're abandoning manual checklists and adopting a highly engineered architecture known as a hybrid control plane.
Okay, let's break that jargon down. Hybrid control plane. I'm picturing something like an autonomous bullet train.
I like that.
Like, the AI is the engine driving at 200 miles an hour, but you can't just put a human in the cabin and tell them to watch out for obstacles.
Huh.
The human reaction time is too slow.
That is a highly accurate way to look at it, actually. To make that bullet train safe, the hybrid control plane embeds 3 distinct layers of governance directly into the software architecture.
Okay, what's the first layer?
The first layer is the policy layer. Sticking with your train metaphor, this is the physical steel track. You don't ask the train to avoid turning left into a field. You build a track where turning left is physically impossible. In a software environment, this means using policy as code tools. You hard code business rules, regulatory boundaries, and ethical constraints into the Kubernetes namespaces or the API gateways the AI operates within.
So you lock it in a sandbox.
Precisely. The agentic system simply does not have the permissions or the network access to execute a command outside of that strict sandbox.
Okay, so if the AI decides the most cost-effective way to source materials is to, I don't know, buy from a sanctioned vendor, the API simply rejects the payload. It hits a steel wall.
Exactly.
What is the second layer then?
The monitoring layer. These are the sensors on the tracks. You aren't just looking at the final destination. You are tracking the engine's temperature and speed in real time.
How does that work technically?
Technically, this involves shadow logging. Every single API, called the AI attempts, is cryptographically hashed and stored on a separate immutable ledger.
Oh, so that's the transparency record for the auditors.
Right. And you run anomaly detection algorithms alongside the agent. If the AI suddenly starts requesting 500% more compute power, or if the distribution of its decisions begins to drift from historical baselines, the sensors immediately flag it.
Okay, so you have the tracks, you have the sensors, and I assume that leads us to the third layer, the emergency brake.
Yeah, the escalation layer. If the sensors detect an anomaly, or if the agentic system generates a decision with a confidence score below a hard-coded threshold, say 85%, The automated workflow instantly pauses that specific execution thread.
It just freezes.
It pauses, and it fires off a webhook alert, routing the exact data payload and the AI's proposed action to a human expert.
Okay, so a human does step in.
Yes, the human reviews the edge case, approves or denies it, and the system learns from that intervention.
That's brilliant.
It really is. You maintain human oversight exactly where the EU AI Act demands it on high uncertainty or high impact decisions, without throttling the thousands of routine tasks the AI handles flawlessly.
Right.
In fact, the data from AetherLink's implementations shows that organizations using this architecture see a 3.2 times faster time to value for their agentic systems.
3.2 times faster. Because the engineering team actually trusts the system. Like, governance isn't a speed bump. It's the guardrails that allow the car to go fast.
Exactly.
But, a hybrid control plane sounds great on a digital whiteboard.
Yeah.
The moment you apply that to the physical world, those neat digital rules inevitably clash with real-world physics and safety.
They do.
Let's look at the tech ecosystem in Eindhoven, specifically the architecture, engineering, and construction sector. They are using AI for building information modeling, BIM, and tracking carbon compliance.
Oh, the AEC sector is the ultimate stress test for the EU AI Act.
Why is that?
Because you have digital intelligence directly manipulating the physical world, agentic AI is actively analyzing architectural designs, testing structural load distributions, and recommending material substitutions to lower the building's overall carbon footprint to meet local environmental regulations.
Which introduces a massive liability tension, right? Like, if an AI recommends swapping out a steel support beam for a carbon-friendly composite material, and that hits your environmental compliance goals, great.
Right, you get your carbon credit.
But if that subtle change slightly alters the structural shear strength of the building, who takes the fall? What happens when the AI's predictive model conflicts with a human structural engineer's intuition?
Well, if your organizational chart cannot clearly answer who takes the fall, your entire deployment is legally non-compliant under the Act.
Wow.
Yeah. AetherLink's consulting arm tackled this exact liability nightmare in their Ethermine case study. They worked with a mid-sized Dutch renewable energy firm that was optimizing wind farm operations.
Okay, wind farms. Critical infrastructure, definitely a skyscraper under the Act's risk tiers.
Oh, a massive skyscraper. So this firm deployed an agentic AI to autonomously predict maintenance failures and adjust the pitch and yaw of the turbine blades in real time based on predictive weather models.
Sounds like a good use case.
It was. The goal was to maximize energy output while preventing mechanical wear. But their governance was an absolute disaster.
What were they doing wrong?
The data scientists owned the AI end-to-end. The same people who wrote the predictive models were also the ones deploying them, monitoring the data drift and signing off on the safety parameters.
Yikes. That is the ultimate conflict of interest. That's like having the pharmaceutical company that invented a drug be the sole entity responsible for its FDA safety trials.
Exactly. You cannot have the builders acting as the sole auditors.
So exactly how did Ethermind go in and dismantle that conflict of interest without, breaking the wind farm's optimization?
They engineered the compliance directly into the data pipeline. First, they ripped out the siloed ownership. They instituted interdisciplinary review boards directly into the deployment cycle.
So more people had to sign off.
Right. A data scientist could no longer push an update to the turbine AI without a digital sign-off from a mechanical engineer and a compliance officer.
That makes a lot of sense.
Second, they implemented dual verification algorithms. Whenever the AI suggested a radical adjustment to a turbine's blade pitch during a storm, that command was intercepted.
Intercepted by what?
It was run through a secondary deterministic physics engine, just a standard old-school software model, to verify that the AI's recommendation wouldn't cause structural failure.
Oh, so they created a digital twin that acts as a physical sanity check.
Exactly.
And how did they handle the transparency records for the auditors?
They utilized the shadow logging technique we discussed earlier. Every single command the AI sent to a turbine was cryptographically hashed and written to a read-only ledger.
Nice.
They built an immutable audit trail that captured the weather data input, the AI's confidence score, the deterministic physics engine's validation, and the final action taken.
And did it slow things down?
Not at all. Within 6 months, they moved from a massive liability risk to 94% regulatory alignment. And their operational efficiency didn't drop a single percentile.
That's incredible.
The hybrid control plane preserved the autonomy while mathematically proving its safety.
Okay, so if you are listening to this and realizing your company's data scientists are still operating in a silo, we need to map out a concrete roadmap.
We do.
Like if a CTO wants to move from that 73% flying blind into the compliant minority, where do they physically start tomorrow morning?
You start by measuring the blast radius. You conduct a formal AI maturity assessment across 5 dimensions: governance maturity, technical architecture, data management, risk management, and regulatory alignment.
Okay, 5 dimensions.
Yeah, and when Aethermine runs these assessments in the Eindhoven area, they consistently find an average of 12 to 15 critical compliance gaps for every 10 AI systems deployed.
Wow, so nearly every single system has at least one major regulatory blind spot.
At least one, yeah.
Here's where it gets really interesting, though. To close those gaps, the sources point to the rise of a completely new, highly specialized role: the AI lead architecture discipline.
Yes.
And this isn't a senior developer, and it isn't a lawyer. This is a technical translator.
Exactly.
Their entire job is to sit between the legal department's abstract requirements and the MLOps team's deployment pipelines. Like, they take a phrase like human oversight from the EU AI Act and translate it into a webhook alert trigger in the CI/CD pipeline.
They're the ones actually building the guardrails.
Right. And the data shows that organizations formalizing this AI light architecture role achieve compliance 2.3 times faster and see a 40% reduction in critical incidents.
They are the architects of the hybrid control plane. But implementing this role comes with severe pitfalls if executive leadership doesn't fully understand the assignment.
I can imagine. What's the biggest pitfall?
Pitfall number 1 is compliance theater.
Oh, the beautifully formatted PDF.
You know it.
The compliance team writes a 50-page governance manual, presents to the board, and everyone claps. Meanwhile, the actual engineering team hasn't changed a single line of code in their workflow. The AI is still doing whatever it wants.
It is a complete facade, and an auditor will pierce it in 5 minutes.
Right.
Effective governance must be hard-coded. The deployment pipeline physically should not compile or deploy a model unless the automated governance checks pass.
Okay, what's pitfall 2?
Pitfall number 2 is deeply underestimating the documentation burden.
Because of the transparency records.
Yeah, the Act requires massive data lineage tracking. Companies frequently realize mid-project that they need 200 to 300% more documentation effort than they budgeted for.
That's a huge mess.
And if you try to reverse engineer documentation after the model is built, like by having engineers manually type out data provenance, your project will fail. The AI lead architect must automate the documentation via codebase annotations and metadata scraping from day 1.
And pitfall number 3 is siloed accountability. You can't just mandate this from the top down and tell the IT department to figure it out.
No, business owners must own the initial risk classification. Data scientists must own the model's statistical quality. IT owns the monitoring infrastructure and the API gateways. And compliance audits the framework's integrity. It is an interlocking ecosystem.
Let me put on the hat of a CPO at a mid-market manufacturing firm, though. Say we have like 500 employees.
Yeah.
I'm looking at this roadmap: cryptographic hashing, AI-late architects, interdisciplinary review boards, dual verification physics engines.
It's a lot.
I do not have the CapEx budget to hire a massive internal compliance army just to manage the AI that was supposed to reduce my overhead in the first place. What is the move for the mid-market?
The mid-market constraint is very real. And it's why the fractional expertise model, highlighted in the AetherLink case studies, is becoming the definitive playbook.
Okay, how does that work?
You do not hire a full-time army of specialists. You bring in specialized external consultants to design the hybrid control plane architecture, build the custom CI/CD integrations, and train your existing engineering team to maintain it.
So you bring in hired guns for the heavy lifting.
Exactly. For a basic footprint, say 5 to 10 AI systems, this fractional model can establish a fully compliant framework in 3 to 4 months. If you are operating at an enterprise scale with 30 or more systems, you are looking at a 6 to 9 month sprint.
Got it.
You essentially rent the architect to draw the blueprints and pour the foundation, but your internal team actually lives in the house and performs the daily maintenance.
That makes a lot of sense. You bypass the trial and error of trying to interpret the legislation yourself, which keeps your burn rate manageable while building internal muscle memory.
Exactly.
Well, we have covered a massive amount of architectural ground today, from the 30 million euro penalties down to the mechanics of shadow logging. Let's distill this into action.
Let's do it.
For me, my number one takeaway is that mindset shift regarding speed. Good governance is an operational accelerator. Building the compliance checks directly into the API gateways and CI/CD pipelines from day one is exactly how you achieve that 3.2 times faster deployment. When engineers aren't terrified of deploying a model that breaks the law, they can actually push the boundaries of innovation.
I completely agree. And my number one takeaway builds directly on that pipeline integration. Accountability must be structurally shared. The era of the isolated genius data scientist deploying a model from their laptop is over. True enterprise AI requires business leaders, IT professionals, and compliance officers to jointly own the architecture.
Well said. And looking ahead beyond the 2026 deadline, what is a blind spot that sources didn't explicitly solve, but that these CTOs need to start agonizing over right now?
I'd say consider the foundation of your architecture. Many of these 30 million year liability enterprise systems rely on foundational open source models as their base layer.
Right.
If you spend 6 months certifying your hybrid control plane, and then the open source provider pushes a mandatory overnight update that subtly alters the model's neural weights,
Wow.
does your entire certified audited system suddenly become legally non-compliant before you even pour your morning coffee? If your AI systems are making hundreds of high-stakes decisions a day, and your human engineers are just rubber stamping them due to alert fatigue, do you actually have human oversight or just compliance theater? How do you govern a system when you don't control the foundational physics it relies on?
That is the exact kind of supply chain vulnerability every board should be interrogating tomorrow morning. For more AI insights, visit aetherlink.ai.